Hi Pre-Calc, we're going to work through page 45 and 46 of notes for day 7 with you guys, and then you guys can work on homework on page 49/50 of numbers 1 through 10. I'm going to go through this kind of quickly, so you might not have time to write the whole thing down. I'll try to go back and post it so that you can write it down again later, or maybe watch the video, then go back and try to write it in on your own, and then go back and check it. Either I'll just use the video again, or I'll try to post it as a PDF if I have time. So on page 45, we're talking about domain and range. The domain is a set of x values that also have a y value. Think about what are okay numbers that I can plug in where I get an okay answer out. Things that you're going to want to consider a lot of times that cause issue with the domain have to do with like square roots, because you can't have a negative number under square root. You can have it equal to 0, but you can't have a negative number. Also, we're going to look at ones where you have fractions or rational functions. You can't have 0 on the bottom of a rational function, and that restricts the domain. The range, of course, is all the answers that come out then, your y values that match up to the x values that you can put in. So we're looking at a couple graphs here, and I'm just going to walk you through how they picked out the domain and range, and then you can come back and fill it in later. So the domain, the furthest to the left you can go, it starts here at -4. And notice it's an open circle. That's why there is a parentheses here at -4. And then it keeps going. Like, it looks like it stops here at 3, but remember that arrow, it keeps going down, which means it's also going to keep going to the right. Your range, then, remember as you're doing your range, you always start from low and going up to the top. Well, it goes down for forever. So we start at -infinity. Remember that always gets a parentheses, comma, and then we are going up to 5 with a parentheses because it's not actually touching 5 there. For the second one here, we're going to keep going to the left. So that is a -infinity. When we get to 1, there's an issue because there's a hole. So we do a parentheses. We do a U, and then we do another parenthesis starting with 1, because we're just leaving out when it's exactly 1. We can be, 0.999. We can be 1.0001. We just can't be exactly 1. And then it keeps going down to infinity, down and also off to the right. So then we have a range of -infinity to +infinity. And with the range there, remember you're thinking of low to high, so that this hole doesn't affect the range because 1 is still in on the graph over here at this spot. For number 3, we have some holes here, but when you're going left to right, even though there's a hole here, you can still put in 1 because you have the solid dot here. And then it continues after 1 with this one over here. So it's a -infinity to +infinity range. And going from low to high, the low spot is -3. And this is going to keep going up. So just this here makes it so it's going to go on for infinity, even without this part over here, because it's going to keep going up, which will cover the kind of gappy spots that we have right here, because it'll keep going up as we go through it. Number 4, we have another one. It keeps going off to the left. So we start at -infinity. Then we have an issue at 1. There's no dot between on this one, so 1 is actually left out. You can't put 1 into this function because both of these are open holes. So we have to do close the parentheses with the -1 and start right up after -1. And then it continues on and it stops at 5 when we go off to the right here. For the range, remember this is pointing down, so it's keep going down for infinity. So even though the graph looks like the lowest part of the picture is at -3, this part would continue on, so that is -infinity. And then the highest pot is up here is about at 3.5. Okay, and that because this keeps going down, even though there's a gap in here, that gets covered because this will keep going down. For this one here, we start at -5. Then we go to here at -1. It has a solid 1, so that's filled in. It jumps here, and then right after 1, it starts up with this graph here. So we're going to go on to infinity. For the range, the lowest spots it hits is -3, and it actually hits there, so that's a bracket. And then this keeps going up for forever, so it's going to go on to infinity. On number 6, you would think there's an issue here at -1, but because this is a filled-in dot, and then this is an open dot, and -1 stays on this graph, but then anything bigger than -1 jumps up to this graph. Where there is an issue is at +2 here, because there's a vertical asymptote. So we have to leave a gap at +2. You can actually plug in the number 2. So we have the parentheses with the U, start with the 2, and then go to 4, because we have a hole here. and then it continues again after 4 going through it. When you look at the range, because these are pointed down, it keeps going for forever down, okay? And this here, where we have the hole here, there would be an issue here if it wasn't for that this over here covers when we have a value of 4 coming out. And then it keeps going up, so it goes to infinity there also. You have a couple graphs at the bottom of the page where we want you to know their basic shape and what kind of domain they're going to have. If you just have f of x equals a number, like f of x equals 2, you just have a horizontal line. There's not going to be any issues with what you can plug in. So it's negative infinity to positive infinity. A slanted line where you have f of x equals ax plus b. Remember, the b is your y-intercept. Your a would be your slope. There's not going to be no issues there, so it also has a domain of negative infinity to positive infinity. This absolute value here, remember the c moves it up. This moves it to the opposite of what you would think. So if it was negative, it would move it to the right, the amount. And this will change the width of it as you're going through it. There's no problems with the domain here also. Where there will be an issue is with the range, because it won't go past the bottom of the v here as you're going through it. But no issues with the domain. For a quadratic function where you have your parabola, there's no issues here with anything you can plug in either, or with your parabola shape, so you can have negative infinity to positive infinity. Top of the next page, we talk about a couple things where there are some issues. One is when you have a rational function. They give us this example here, and we're going to actually go through working with this in a second, but you'll see where there's an issue with the domain where you have vertical and horizontal asymptotes working with the rational function. With the square root function, we also can have issues there because you can't have a negative under the square root. Remember, you can be equal to 0 though when you work with that. The cubic function, remember, looks kind of like a sideways S. There's really no issues with that because unlike things that are taken to an even powered root, okay, like there would be issues if you had a 4th root or a 6th root. But odd powered roots, you can still put negatives in underneath it. And so this has a domain of negative infinity to positive infinity. And I'll try to come back to this page after we do the next part here. So here's the first function. They want you to plug in the f of negative 2. And when you plug that in, make sure you square, work this out, okay? When you do the bottom, negative 2 squared will be 4. 4 minus 4 gives us a bottom of 0. Anytime you get a bottom of 0, that's going to be undefined. Okay, so we find that at f of negative 2, so when x equals negative 2, all right, it's undefined. If we go back to our picture here, that makes sense. To see here at negative 2 how it's undefined, we can't put in negative 2. The graph is jumping from this part up to this part as you go through it. They also want us to do f of negative 1. Okay, when you plug that in, work it out, we get 2 for an answer. If we look back at our graph at negative 1, here's that dot for 2 to come out for an answer. So you see how they kind of line up. So over here they have an explanation. When x equals 2, there is no y value, but when x equals negative 1, there is a y value. Thus, negative 2 is not in the domain, but x equals negative 1 is. For the second function here, the square root of 5 minus x, if I plug in negative 4, out comes an answer of 3, and that's fine and good. But if I plug in 9, 5 minus 9 will give me a negative, and it's undefined. So we can see here that when x is negative 4, it's in the domain because it has a y value. But when we plug in 9, we can't do that, so it's not in the domain. Which makes sense as you go back and look at this, okay? We're okay plugging numbers in until we get to 5. And then anything bigger than 5 is not gonna work because when we plug them in, we're gonna get a negative under the square root. And we'll get more into analyzing that tomorrow. For the cube root function, if I plug in negative 2, or sorry, if I plug in negative 11, I work it out and I get negative 2, which is okay. And if I plug in 5, I work it out and I get 2. So both of them are in the domain here, and really everything's going to be in the domain for this cube root function. There's not going to be any issues as we're looking at it. Okay, so I want you guys to be working on your homework, not on the next page, but the following page after that. I think it is page 49 in your packet. Try to do work on numbers 1 through 10. We'll talk more about the ones that are in the 11 through 19 section tomorrow. Have a good day, you guys.